Welcome. We are working on modified box and whisker plots, day 2 basically, so 5.3b. So here's another sample of data. So these are 50 shoppers and the amount of money they spent. Notice there are 10 data values for each row. The data has already been arranged. So if there's 10 per row, there's 5 rows, so that means there are 50 data points. So n equals 50. So we want to find the median, Q1 and Q3. So this is where, you know how we talked about in the last video, the median is the middle number. Well, if you wanted to sit here and cross them off, you could, but it's going to take you a while. So I'm going to find the position. So I'm going to do 50 plus 1, divide it by 2. Right, so you get 25.5. So it's between the 25th and 26th number. That's not the number. It's not 25 or 26. It's not 25.5. It's between the 25th and 26th number. So if you count, you get right here. So the median is 20. Because they're both 20, the middle number between 20 and 20 is 20. So that is the median, 20. So this is your median. Okay, so the median is 20. So then we find the middle of the bottom half, right? So again, depending on how you want to do that, you can count, but you should get Q1 is 14. Or if you wanted to find the position, right, there's 25 numbers. So 25 plus 1 is 26, divide by 2, so it's the 13th number. So 10, 11, 12, 13. Same idea with Q3, right? It's the 13th number. So 10, 11, 12, 13. So that's Q3. So this is 13. Sorry, not this, the 13th number. The actual number is 34. So that's the 13th number is the position. Or you could have counted. Either way, right? You can always find the position once your data is in order of the median or any middle number, because really Q1 is the median. It's just the median of the bottom half, right? It's the middle of the bottom half. So we want to check for any outliers and then make a box and whisker plot. Okay, so to check for outliers, remember that's the inner quartile range. We need that. So we need our IQR, which is Q3 minus Q1. So that would be 34 minus 14. Right, that's 20. And then we're going to times that by 1.5 to help us build our boundaries. So 30. So what we do is we take Q3 and we add 30. And we take Q1 and we subtract 30 to get our upper boundary and our lower boundary. So you should get 64, right? Q3 is 34, so 34 plus 30. And then we have 14 minus 30, so we get negative 16, right? Negative 16, no one spent negative $16. The store wasn't paying you $16 to shop. So if we're going to have an outlier, it's going to be a high outlier. Right, it's going to be above 64. So are there any numbers above $64? Yes, 68 and 72. So these are both outliers. So 64 will be our new maximum value. Right, this is our new maximum value when we do our box and whisker plot. So our low is 2, right? That's our minimum value. The left side of the box is 14, right? So 14. The median is 20. And then 34 is our right side. And now our whisker is going to go to 64. And our outliers are going to be 68 and 72. There we go. So there's our modified box and whisker plot. So again, median, middle number, Q1, Q3, quartile 1, quartile 3. Middle of the bottom half is Q1. Middle of the top half is Q3. We need the inner quartile range, right? Remember range, right? The difference between two numbers. So Q3 minus Q1 times it by 1.5. It's just a multiplier, so it's always 1.5. Using that number, that doesn't determine outliers. We use that number to build our boundaries. So we add it to Q3 to get the upper boundary, subtract from Q1 to get the lower boundary. So our new maximum value was 64 because 68 and 72 were outliers. And we mark those on our box and whisker plot by stars or something that makes them stand out. Okay, so last two examples. Suppose you have 301 collectibles between $50 and $500. You just bought one for $40. So we have the mean, median, mode, standard deviation. So we're going to try to determine, is it increasing, decreasing, or do we just not have enough information? So mean. So you just bought something, your average was 50 to 500. You'd add all those numbers up, divided by however many you have. You just bought a value, you just bought a collectible that's less than what you had as your lowest value. So now, is your average going to go up or go down? So your lowest value was 50, now you just bought one for 40. So is that going to drag your average down, or is it going to pull your average up? Right? It's going to decrease it. Because now, right, you have to add that 40 in. It's a lower value, so your average is going to go down. If you would have bought something for like 600, then that would pull your average up. Okay, what about the median value, the middle value? So you have 301 items, so between 50 and 500. We don't know what they are. So we don't know what the middle value is. So $40, right? We don't know if that's going to affect the median, right? It's going to move it, but we don't know. What if all three middle numbers are right in the middle are, all 400, 400, 400? Maybe that's the middle value. So if you moved it down one, it's still 400, right? You moved it up one, it's still 400. We just don't know. There's just not enough information. The mode, remember, mode is what number occurs the most. Well, we only know that you have a 40, a 50, 500. We don't know what the other numbers are. So there's just, again, not enough information. Okay, standard deviation. Well, that's how far the data spread out. So the data was from 50 to 500. Now I added a 40. So what does that cause your data to do? Did it shrink or did it spread out? It got wider, it spread out. So if it spread out, that means your standard deviation increased. Okay, so now let's say instead of buying a $40 item, I bought a $900 item. What is that going to do? So now my average, I bought something that was more expensive, right? Think about like your average test scores. If you do better on the test, it pulls your average up. If you get your lowest score, it pulls the average down. So this is going to increase. Median, same argument we had before, right? Middle value, I don't know what that is. I mean, I could have 5 numbers in a row that are all the same. So if I add an extra number, I could be getting the same number over and over. It might not be increasing. So there's just not enough information. Mode, again, I only know 3 numbers, 950, 500. I don't know what the other numbers are. So I don't know if they repeat or if they're all different. And then standard deviation, how far the data spread out. So it was 50 to 500. Now it's 50 to 900. So your data, right, is now more spread out. So if the data is more spread out, that means your standard deviation increased. Again, remember mode is how often the number appears in the data. So again, mean, if you get a larger value, that increases your mean. If you get the lowest value, it decreases. The standard deviation, if you spread out the data, your standard deviation increases. If you shrink the data so it's not as spread out, your standard deviation would decrease. So to finish up your notes, make sure you answer the essential question at the top with your summary, 3 to 5 sentences, and you will be done. Have a great day.